and welcome to Extra View Content Lecture 1 for CSWP. I am Luke, the Vice President and current CSWP lead at the time of recording this. Today, what we're going to be doing is just introducing a couple of new features, while also recapping a lot of the tools used in CSWA to really just push you to the next level of the certification that defines the professional level. I'm not going to spend too much on introduction other than that because, you guys should know the drill by now. So we're just going to kind of get into it. First thing I am going to show you, though, is how to get rid of the stupidity that is SolidWorks 2025 UI. So I'm just going to go ahead and open up a new part. And if you're on 2025 or a later edition, you're likely seeing what is known as the simplified interface. I'm on 2024, so I actually don't have that, but regardless, some of you will, so I'm going to show you how to turn it off because CSWP is going to require some tools that you actually can't access normally on the simplified interface. So thank you for that, Dassault Systems. So to turn off this, we're going to go up here to the SolidWorks logo and kind of hover over this arrow. And then we're going to go to View, Workspace, and if you're on 2025, you'll have the option over here to uncheck Simplified Interface, which you're going to do. And it'll kind of like restart your SolidWorks real quick, and then you should have something similar to what I do after that. Again, like I said, I don't have that option because 2024, but 2025 is very silly, so here we are. The other thing you're going to need to do before we start is enable an additional tab. You'll notice that I have like a ton of tabs up here because I do a lot of things. Go figure. To enable these things, all you have to do is come up here and right click in the ribbon up here and you go to tabs. The one that we're going to need is this direct editing tab. So go ahead and enable it if you don't already have it enabled. You can turn anything else on that you want to as well, but direct editing is what we're really going to need that you don't have default. Okay, that's enough talk for me. We're going to go ahead and get started on creating your first ever CSWP part. Yay! We're going to be making this here shield that is supposedly from a very famous and popular video game. I wouldn't know. I have no idea. Regardless, the first three things stay the same from CSWA, which is you're going to first do your unit system, which is MMGS. I'm already in an MGS, but if you're not, go ahead and change that. Your material. For our material, we have chrome stainless steel. So you're just going to come over here and right click, edit material. And you're just going to look up chrome stainless. Go ahead and apply it. And then close. And then the last thing is equations, which we don't have any equations, so we're good here. Okay, so this is kind of a weird shape, so we're going to take this one step at a time. The first thing I'm going to do is this center cylinder here, and then I'm going to make the extrusions on the sides, then this cut on the inside, and then finally the detailing. The reason I'm telling you all this right now, as opposed to, while I'm doing it, is because with CSWP, it is very important to keep in mind design intent. So what is the way that you're going to make this part? And if you were to create this drawing or to have anyone else do it, how would they be able to replicate what you're doing? So that's really what we mean by design intent. And it's what sets the professional certification apart from just your regular old associate. And it's what your boss in the future is going to want to be seeing from you. Anyway, I'm going to start on the top plane. Just creating a new sketch here. And I'm just going to draw the circle and dimension it to the 40 millimeters shown in the drawing. And then I'm just going to extrude it up. The extrusion distance is shown right here. So I'm going to go to Features, Extrude Boss, and it's this one here, this 500 millimeters. So you just have a nice little cylinder. I'm going to turn off Real View because it will hurt my eyes. Okay, and like I said, now that you've got that, the next part we're going to be doing is this, the actual shield itself. We're only going to be making half of it because we're going to mirror it afterward. So I'll start a sketch on the front plane. And I'm going to start with a line down here that's kind of offset from the origin. So just somewhere, it doesn't really matter. We'll dimension it later. Just make it vertical, just like so. And now I'm going to start drawing out the rest of my shape. So I'm going to start with a 3-point arc. It's going to go start down here, and then just somewhere. And then the last point, again, just kind of somewhere. We'll do all the dimensioning later. And then I'm going to draw this line right here. I'm going to then draw this tangent arc right here, like so. And then the line here to connect it. Pretend I connected that. Okay. And now what I'm going to do is I'm going to add the tangent relation here that should have been added, but it wasn't because SolidWorks decides when it wants to work and when it doesn't. So I hold Control on my keyboard and select both lines, and then just add the tangent, just like that. I'm going to kind of position this so it starts to kind of look like what I want, or I won't if SolidWorks doesn't want to behave. That's fine. You know what? That's all right. Okay. So we're going to start with my largest dimension here, which is this 495 height. And then the next largest would be the radius of this big outside area right here. So that'll be 500 millimeters. The next thing I'm going to do is I'm going to come down to this detail view and take a look at all of these dimensions here that I have to now add in. So this here is 25. This is 45. This is 100. The radius of this circle is 75. And then there's this height here of 50. That's to the center of the radius of the arc. And then I'm still underdefined because I'm actually missing one more dimension. It's right down here, this 17.5. So that's going to go from this line here to the center of my cylinder, which just happens to be conveniently enough on the origin. So that is 17.5 millimeters, like so. And now you can see my sketch is fully black, so we're fully defined now. Just kind of position things so they're more readable. And then I'm going to go ahead and make my extrusion now. So I'm going to go to Features, Extruded Boss. And we don't want it to be 500 millimeters blind. We want this 15 millimeters, and it's going to be a mid-plane extrusion. So I'm going to change to mid-plane and make it 15 millimeters, like so. You should have something that looks like this. So next thing I'm going to do is I'm going to flip myself around like so, and I'm going to make this backside inset cut here. So in CSWP, you're going to see some drawings that have letters on them. Scary, I know. Letters instead of numbers. Ooh. What the TYP here means is it means typical dimension. So that means basically wherever you see a dimension that looks something like that, unless it is explicitly stated otherwise, it is probably that 10. For us, that's usually going to indicate that there's an offset somewhere. You might also see something like SYM, which is symmetrical, or any other things that we decide to throw at you. It's usually pretty easy to decode, or if you don't know, Google it. So what we're going to do now is I'm going to start a sketch on this back face. And now I'm going to do the offset that I mentioned. And instead of, I could just select this whole face and then reverse it. But if you notice, there's this 50 dimension up here. So if I were to do that, this would not actually be 50 millimeters. So I'm going to go ahead and confirm it. You shouldn't do that, but I'm going to do it anyway, just to kind of prove my point. If I do this, whoever made this drawing is evil. So that's actually 48.45. So I'm going to undo that. And instead, I'm just going to go and offset entities. Make sure that select chain is turned off because otherwise it will just do the same thing that I just did. And I'm just going to individually select my edges like that and make sure that it is reversed inwards, or yeah, just make sure it's going inwards, and then just confirm it like so. And then I'm going to manually add in this line like so. I'm going to make it vertical because for whatever reason it didn't make it vertical. And I'm going to add the 50 dimension up here. Okay. And then I'm just going to come up and I'm going to trim this excess away up here. While I was on the subject of trim, I do want to introduce something that hasn't made it into the extra review content, but is still an important thing and a nice little quirk about trim entities is this keep trimmed entities as construction geometry. So if I were to turn this on and then I trim across this line right here, you can see it turns it into a construction line. This is super useful if you're trying to, like, say, create an arc of some kind and you're using a circle, or you're just trying to keep whatever geometry you want, but you actually don't want it to be extruded, something along those lines. So basically, most of the time when I trim things, unless I know I want it gone, I will use this tool. CSWP is a lot about finding little niche optimizations you can do, and that's just one of the many ones that we're going to go over throughout this course. Okay, with that said, I'm going to now go ahead and do the cut inward. So I'm going to go to Features, Extrude Cut, and from this section view AA, I can see it is 10 millimeters inset. So I'm going to change this 15 to 10, confirm it, and we are now inset just like so. Okay. And now I'm going to turn my attention to the little design that was placed on the front of the shield. So I'm going to turn my shield around again. And I'm going to start my sketch here on this face, on the front side. And I'm going to draw 3 lines here. One that's kind of above the origin. If you do it in the right spot, it'll actually snap like so. Come down, and then one that's parallel to that line. So you can add the relation manually, or if you kind of wiggle your line around enough, you'll actually get a snap like this. And if I confirm this line, it automatically adds the parallel relation. If that didn't happen for you because SolidWorks chooses when it wants to work, that makes sense. You can just hold Control, select both lines, and add the parallel relation. Same with this. I want it to be vertical from the origin, and it actually automatically did that with this here coincident relation. But again, if that didn't happen to you, just go ahead and hold Control, selecting the vertical line and the origin, and you can make them coincident, and it'll effectively extend a line out this way. Okay, so now I'm going to start adding my dimensions. Thank you. I'm going to add 50 millimeters right here. I have a 350 from this point here on the end to the origin, like so. And then I have a 40-degree angle between this line and the bottom of my pillar, like so. So now we actually do need to close the contour though, because you can't extrude an open contour. So we're going to use our handy dandy convert entities to select this side of the shield, take that whole edge, bring it into our sketch, and then trim away what we don't want. So what's on the top and bottom there, just like so. And I'm going to confirm my trim. And now I can go ahead and extrude it to the 2.5 millimeters indicated in this section view. So I'm going to Features, Extrude Boss, and change it to 2.5 millimeters. I do want this to be a blind extrusion, not a midplane. So I'm going to change that from midplane to blind, just like so. And just like that, you have half a shield. Yay! So all I need to do now is I need to mirror it across the plane right here. So I'm going to go into my mirror tool. I'm going to click my little drop down that's right up here where it says part 4. And I'm going to select my right plane as my plane to mirror about. If you haven't used Feature Mirror before, I'm sure you've used Sketch Mirror. So instead of using a 2D object, so to mirror a 2D object, right, you need a 1D line. So if we're in 3 space, you have to use a 2D object to mirror a 3D extrusion. So I select my right plane for my face to mirror, plane to mirror, whatever. And then my features that I need to mirror are going to be all 3 of these that we have added. This boss 1 is your middle, so you don't need to mirror that. And when I confirm, you can see I now have a completed shield, just like is shown in the isometric view. So now if I go to evaluate mass properties, did it right, you should get 12,523.86 grams. That is a hefty shield. If you can pick up this 12 kilogram shield and like use it properly, more power to you. So with that said, we're going to go ahead and move on then to the next part of this, which if I scroll down, it says part 1. It should say part 2. I don't know why it says part 1. Regardless, you can see they have slightly modified the shield. So a lot of CSWP is not actually creating your own parts, but it's a lot of editing existing parts. So you'll be given a part to like say download, and then you're going to have to make some modifications to it and make some changes. So that's what we're going to really be augmenting here. And I'm going to show you a couple of niche ways that you can make your part editing go a lot smoother. So the first thing I'm going to do is I'm going to add this here centered circular cut that you can see from the top view and in this section view here. You could come in and add a cut straight down, but instead I'm going to use my features smartly, and I'm going to just edit the sketch that this boss extrude was from, like so. And then just add a circle here to the diameter that I want, which is 15. And if I exit my sketch, you can see SolidWorks is a smart little cookie, so it decided to add the hole all the way through, just like that. Okay. So the other main difference that you'll notice about this shield is we now have this kind of inset here. And we need to go ahead and replicate that. In order to do so, we're going to use a revolved cut. But if I were to revolve cut here, it would take out like half of my shield, right? So I'm going to show you guys a really cool way to what we like to call time travel in SolidWorks. This blue line down here is not actually just for show on your feature tree. It's not just for show. It actually does something. If I click and I drag it up to say before the boss 3, it has suppressed every single feature that is below it. So then if I move it back down, you can see my shield is back. So this bar is called the rollback bar. And like I said, it literally moves your part back to an earlier rendition of it. So in order to make this cut, this revolve cut, I'm going to roll back to before my shield part even is existed. And I'm going to add the cut right here to just my pillar. So sketch on the front plane, and I'm going to add this area that I'm going to need for my revolve cut. So I'm going to use just a rectangle like so, and then just dimension it. 15 millimeters on top, 5 millimeters in width, and then 15 millimeters from the bottom. And now I'm going to go and make my revolved cut. You'll notice though that we need an axis of revolution. and I actually didn't draw one. That is because I am lazy, and I don't feel like drawing one. So we're going to use a handy-dandy tool that exists within SOLIDWORKS itself to create this axis revolution out of nothing, essentially. So there's a lot of tools up here in the top bar. I'm sure you guys have used section view, potentially even this view display style one or this view cube. There's also this eyeball one that is the hide show items. So if I click this drop down, you can see there's a bunch of options that I can select on what to hide and show. Go figure. So like for example, if I click this hide show primary plane one, you can see it displays the front, top, and right plane for me, just normally, automatically. I'm going to go ahead and turn that back off. The other one that we're going to be using, that you'll notice, and one that we're going to be using here for this revolved cut, is this one here that says View Temporary Axes. If I turn this on, you can see it has added this axis here that actually goes for my cylinder. Once again, CSWP is a lot about very small optimizations that will help you save time on your exam. So this temporary axis is just one of those ways to do that. So if I click on that, you can see now it is giving me the preview that I want to make this revolved cut. If I confirm it, you can see it has added this revolved cut as I want. So now I'm going to take my rollback bar and just drag it back down. You can see something is broken. That was supposed to happen, I promise. So I'm going to go in and I'm going to edit the sketch to go figure out what the error is, and you'll see this 50 millimeter has turned this kind of weird dark yellow color. You're going to get errors pretty often when you use the rollback bar if you don't, plan ahead about how you make things. In this case, I actually planned for this error to happen to show you that errors are normal, and a lot of CSWP is all about how you handle errors and how you make edits like this. So this dark yellow here is what is called a dangling dimension. Essentially what happened is SOLIDWORKS was referencing something that actually no longer exists. So when I had made this dimension before, I had dimensioned it to the edge here, the cylindrical edge that went all the way down this part. That actually doesn't exist anymore. So it is throwing an error and getting upset at me for it. So I'm going to go, all I have to do to fix this is just delete this dimension and then re-add it. Just like so. And it stays 50 millimeters from before. So now if I exit my sketch, problem solved. Yippee. But we're actually not done. If you look at my shield and you look at the shield over here, there's a gap on my shield. I don't know about you guys, but a shield with gaps in it doesn't seem very effective for blocking anything. Just my personal idea. If you want to, prove me wrong, go ahead. I am open to discussion. But for me, I'm going to close off my shield by changing this dimension down here, this 12.5. If you remember from the first part, there was this 17.5 dimension that we added. It is now actually changed to a 12.5. So in my Boss Extrude 2, I'm going to edit the sketch and change the 17.5 to a 12.5. And you can see it shifts over the whole shield, just like so. If I exit my sketch, everything should now be fixed. And if I go to evaluate mass properties, you can see that my new mass is now 10,164.33 grams, which, again, a little bit more manageable than the last one, but still pretty heavy. So more power to you if you want a 22-pound shield. With that, we are actually done with the shield part. So to recap what we went over is we did feature mirror, we did cut revolve. I showed you guys some niche uses of like certain tools like trim. And then we also used this rollback bar to make an edit after we had already made features. And then obviously dealing with the errors that came with it. Some fun stuff. So the next thing we're going to do is we're going to now move to this yellow submarine, courtesy of the Beatles. So I'm going to go and I'm going to make a new part, come up here, maybe come up here to where it says new, and I'm just going to make a new part. Once again, we're going to do our three things first, which is our unit system. This one is an IPS. Our material is alloy steel. So I'm going to go right click, edit material, and type in alloy steel. You want alloy steel, not alloy steel SS or cast alloy steel. Those all have different densities, as you can see. I guess these two have the same density. No, they don't. I'm stupid. They all have different densities, so we want to match it with the one that density is listed right here. So that would be this regular alloy steel that has a mass density of 7,700 kilograms per cubic meter. So I'm going to apply, close. And then once again, there's no equations, so yippee, we can go ahead and start our part. So this thing is really daunting and scary looking, but it's actually not that bad, and I'm going to show you guys how to make the most of your features to create a part that looks something like this. So the first thing I'm going to do is I'm going to start on my view with my most dimensions. So that would be right here, this front view. So I'm going to sketch on the front plane, and then I'm just going to draw out the basic shape of it. So some lines that go like this, here, up here, horizontal, and then back to close. You'll notice that I didn't add any of the fillets here. I'm going to add them as sketch fillets once I have dimensioned everything else. So now I'm just going to start making my dimensions. Like last time, I'm going to start with my biggest dimension. So that's this 3-inch dimension right here. And then I'm going to do the rest of the ones that are on the bottom. So this 1 inch here, and this 3/4 of an inch, like so. And then same for the top. Biggest dimension is 2.5. Then 1.5. And then another 1.5 inch. And I'm going to add this 45-degree angle. I'm going to select these two lines. It'll give you a 133 or whatever kind of angle you have. And I'm going to drag it outwards like so, and then place it so I can get my 45-degree angle shown on the drawing. And then I'm going to also add this 135-degree angle. And now I'm going to start on my two vertical dimensions, which are these 1/2 inches. So there's 1/2 inch here. And a 1/2 inch on the far side. And then the last thing I'm missing is this 1 inch right here. Just like so. And now I am fully defined, once again, as indicated by all of my lines are black. And if you look down in the bottom corner, it says fully defined on my sketch. I'm actually going to also add these circles here before I make my extrusion. So I'm just going to draw a circle like so. And I'm going to make the dimensions. The porthole is 0.4 inches in diameter. It is 0.1 inches from this line, or from this vertical here. And then it is 1/2 inch down from this horizontal. Okay. And now I'm just going to, I could draw 3 more, but I'm lazy, so I'm going to just pattern it. So when you go to linear sketch pattern, and for my entities to pattern, I'm going to click down here in my pink box, select it, change it to 3, and then make my dimension to be 0.7. Before I confirm, there is something that you guys are probably very familiar with, depending on how much you've used linear or circular sketch pattern or any kind of sketch pattern in general, which is that when I confirm something like this, it usually makes it so it's underdefined. So if I confirm, I would recommend you guys not confirm yet, but I'm going to show you just for the sake of showing you. You can see I actually still have blue. Even though I dimensioned it to 0.7, I can still drag it around. I don't want that. So if I go in and I edit my pattern, I can change this back to 0.7 and press dimension X spacing. And if I confirm now it is fully defined and it has added this 0.7 dimension here, just like so. I would highly recommend that whenever you're going to do any kind of sketch pattern, you decide what kind of dimension you want to add to it, and it will automatically add it for you. So there's different ones for circular and other types of sketch patterns and other kinds of movements, whatever that you need on here. Okay, and now I'm finally going to attack these sketch fillets that I purposefully avoided earlier. So I'm going to go and use my sketch fillet tool, change it to 1/4 inch in radius, and it says there's 5 of them. So I'm going to count 1, 2, 3, 4, and 5. I'm going to keep this constrained corners active because if I remove it, it is actually going to delete some of my relations or some of my dimensions here. If I keep constrained corners and press check, you can see it adds these little extra lines here and this intersect relation. That's very important because I have dimensioned things from the edges here. If I had turned that off, then it would get rid of these dimensions. So I can confirm that. And now, at long last, I am finally ready to extrude this thing. So I'm going to go into my features, extruded boss base, and I'm going to do only half of it for right now. So I'm going to use this 3/4 inch dimension to do a blind extrusion, like so. So once we have this, I'm now going to attack the top side of it. I promise the rest of this is not going to be anything sketching intensive. Let's say that. So I'm going to start a sketch up here on the very top of it. It's important that I go on the very top of my boat. Otherwise, my extrusion is going to be wrong. So start a sketch here. And once again, I'm going to just draw out the general shape. So like so. And this needs to go right here. Okay, and then I'm going to just go ahead and add my dimensions, the very few that exist. So this 1/4 inch right here. And then this 2 inches right here. And now that I've dimensioned everything else, I'm going to add my sketch fillet of 1/4 inch of radius. Okay. And now I am going to go ahead and mirror this. So I'm going to go to mirror entities and I'm going to box select everything by clicking in the blank area and dragging over all of my lines. It automatically will select everything. I'm going to then mirror about this edge here or just any of these edges. And my yellow preview will pop up to show me that it is in fact mirroring the way that I want it to. Confirm. And now we are ready to extrude. So we go to features, extrude boss base. And we're going to do a couple of really weird things with this one. So the first thing is we're going to use a type that you may not have ever used before, which is a through all. Might have used it for a cut, but not for a boss. You can see it's actually not extruding anything, but if I flip it around, it goes through the entire part, just like so. You're probably wondering, why are we extruding something through the entire part? Well, you're going to find out here, and it has to do with that direct editing that we enabled earlier. Before we do anything, though, I'm going to uncheck this merge result button. Merge result does is it adds your existing extrusion to whatever extrusion you're making. So it makes it all into one solid body. What I mean by that, you're about to find out. So once I confirm this now, you can see I now have 2 overlapping areas here. And something that you'll notice that you've probably never paid attention to before is there's this solid bodies folder that now has 2 entities inside of it. one for the first extrusion and one for the second extrusion. And if I kind of spin it around, you can see that they're overlapping in places. This is very important for what we're about to do next. So with that, I'm now going to go to the direct editing tab that I enabled at the start of this video. If you didn't enable it already, I'll show you again. If you right click in the ribbon up here and go to tabs, you can find all of these fun tabs here. And the one that I need is direct editing. So I'm going to go to my direct editing tab, and you should have this combine feature right here. So if I press on it, you'll see it'll bring you this screen, and you'll see there are 3 different types of combine. We're going to be using combine common, but I'm just going to show you what each of them do for the purpose of, learning and understanding a new tool that you guys have never used before. So what add does is it takes 2 solid bodies and makes them into one. So you can see it got rid of the portholes, and I now only have 1 solid body. So what does that tell you about combine? Well, you need to have more than 1 solid body for it even to work. You can see it's even grayed out now that I have 1 solid body. So I'm going to go and edit my feature again. And I'm going to now show you subtract. So what subtract does is it takes away any area that's in between them. So if I choose, let's say this, the second extrusion as my main body, and I subtract the first extrusion, it literally leaves like a hole where it was. And then the last one, which is the one that we're going to be using, is common. It is basically a combination between subtract and then it's kind of a combination between the two, but what it does is it takes that subtraction area and it gets rid of everything else. So if I show preview on this, you can see it's literally taking that area that was subtracted before and it's turning it into my remaining shape. Apparently, I learned the other day that this is called like a Boolean in Blender or something. I don't know. I don't use Blender. I'm just a SolidWorks guy. But when I confirm this now, you can see now my shape is actually starting to look like what I want it to. Just perfect. So I hope I explained that very nice and well for those of you using Combine for the first time. Otherwise, the next thing that we need to do now is hollow out the inside of our boat. You can see it's got all of this missing stuff here, and there is a 10.1 typical dimension here. So what does that mean? Like I said before, it means there's some kind of offset. But we're going to use a different kind of offset than one that you're probably used to, and maybe one that you've ever even used before. This offset is called a shell. What a shell is it takes your selection and hollows out everything else. So I'm going to keep my parameter at 0.1 inches. It is up here in the features tab and right below draft, by the way, next to like fillet and linear pattern. I'm going to select these 3 faces right here. And when I confirm, or when I show preview, you can kind of see what it's going to do, but not really. But when I confirm, you can see exactly what it's done. It has literally taken away all material up to 0.1 inches away from the backside. So if I were to go and I were to measure this to here, the distance is 0.1 inches. So pretty useful when you want to make something like this. And if you do the homework for this, or if you've already done the homework for this, you'll know you use shell for the water bottle assembly that you either have made or are going to be making. Okay. And last thing that I want to do now before I mirror is I'm going to now add all of these fillets. If you look at this here section view, there's a 0.05 inch typical fillet. So I'm going to go to fillet and I'm going to change my parameter to 0.05. And I want to make sure that this checkbox here that says show selection toolbar is selected. I'm going to select one edge and I'm not going to move my mouse. If you move your mouse, that's all right. You can always exit out of the fillet or try to just select a different edge. So I'm going to move it away just to show you if I select a different edge, this toolbar pops up again. This is what I'm looking for. And you can see it's giving me a bunch of different options as to what I can choose for all of these edges that I can fillet. For a typical fillet, so when it says 0.05 typical, you're going to want to use the one that says internal to feature most of the time. For our cases, you're going to want to use internal to feature every time. In the real world, sometimes it'll mean you need to select a face, or you need to select like all edges or all concave or whatever. But for our case, and for the purpose of CSWP as a program, you are going to use internal to feature whenever it says typical for a fillet. So I'm going to select that, and you can see it propagates 28 edges. So I don't have to go in and manually select all of these edges here on my boat, which is super helpful and super nice, given that that's 28 edges that I would have had to select. So now when I confirm it, you can see it has now filleted the inside everywhere, all the way around, just like shown in our isometric view here. And now finally, at long last, we only have half a boat, so we're going to make the other half. Once again, we're going to use mirror. My mirror face plane is actually just going to be just this face on the back side of my extrusion. And for my features to mirror, I want everything from my combine downwards. So combine, the shell, and the fillet. You can select the other extrusions, but it's not going to do anything because they don't exist anymore due to the combine. And now when I go to confirm it, I am actually going to get a rebuild error. It says, unable to create instance for pattern, try again, decreasing number of instances, distance between instances. I am mirroring. There is only one instance. So it's, again, just SolidWorks being very silly about terminology. What does this really mean? It means I need to select this button down here in options that says geometry pattern. Geometry pattern will allow me to properly mirror the shell so that it doesn't intersect with itself. If you watch the CSWA review video that is linked at the top of the homework for this week, you'll see I'll go into detail on what geometry pattern actually means and what it actually does. Regardless, if you select geometry pattern, I can now confirm, and would you look at that, we have a submarine. It's not yellow, so I'm going to make it yellow, just so that we all live in a yellow submarine. Maybe. There we go. And so now I can go ahead and take my mass, so evaluate, mass properties. And you can see it has the mass of the finished part up to 3 decimal places, but I actually only have 2 decimal places. So what I'm going to do is I could go into document properties and change all of my options to all my settings and all of that to have 3 decimal places. Or I could press this options button up here in mass properties. It brings up these extra options here. I'm going to change it from use document settings to use custom settings and increase the number of decimal places from 2 to 3. And then I'm going to confirm it. And would you look at that? Now it says 0.974 pounds, which is exactly the mass of our boat over here. So I hope that made sense to you guys. A lot of really weird stuff going on with this part. But it's really one of the only good workflows for something like this. And understanding how to mess with multiple solid bodies in your part is actually a huge step forward in having to do higher level and more advanced modeling techniques. Especially if you go on to take things like surfacing or mold design or what have you. Okay. So, last part, I promise this one's super duper easy. The second part of the yellow submarine, it has us change the shell such that only the portholes have a 0.05 typical, as opposed to the 0.1 typical that was originally here for the shell. So I'm going to go in and I'm going to edit my shell, and I'm going to click on my pink box. Before I go and select any of my edges here, I am going to change the number to 0.05. And then I'm going to go in and I'm going to select. The reason I went and did this first is because if you look, if I change this back to 0.1 to the original, it only changes the one that I'm currently selecting. So if I then switch to phase 5, you can see it's individually dimensioning everything. So if I go ahead and add that dimension first, it avoids this issue of having to go in and individually add the 0.05 inch to everything here. So to now confirm it, and usually look at that, much smaller portholes. And if I run my mass properties, again, I have 0.88 pounds, which just so happens to be the amount specified on this document. I hope that was helpful for you guys. As always, if you guys have any questions or anything like that, feel free to reach out on the Discord and help desk. And I hope that this makes things that maybe weren't as clear in the workshop, or if you needed some extra practice with something like this, I hope this has helped you. Regardless, thank you guys for watching, and we look forward to seeing those high scores on the exams.